So now we have the animation interface set up. We're going to create the states to have them play in the game. So I'll go to the player scene, and as a child of the move state, we're going to create a new player state. So Control A. Oh, I need to go back to the scene. Control A to add a new player state, and we're going to name it idle. Right click, extend the script, and we'll save it to the state directory. I'm going to save my scripts and close the other tabs. Now, this state is not going to do too much. It's just going to leave the player working idly. Now, for pretty much every state, you want to reuse the base interface of the state class. So I'm going to press Ctrl-Alt-O to open state.gd. And from there, I'm going to copy the few functions that we have there and that we need to override in our idle state. I'll copy them, go back to idle.gd and paste them. We're not going to use process on the character. We'll use it on the camera, but the player being a physics body, we're going to use physics process instead. Now for each of these, the base is to delegate the call to the parent, or to also use the parent move states, unhandled input function, physics process, etc. So the first thing you want to do is go underscore parent dot, and we're going to call unhandled input on it and pass the event. So you're going to do that the same way for physics process. We pass the delta parameter, enter, we're going to pass the message parameter, and finally exit. That is the boilerplate, if you want, for each of your states. We do that first and foremost because, for one, you can copy that code, save it somewhere and paste it in new states, or if you use a separate text editor from Godot, you can set templates or snippets for that. Then we want to make sure that we always carefully call the functions on the parent that is supposed to do some of the work already. So our move state, for example, moves the character in the physics process function. It updates its position, its rotation. So we want to ensure that we always update that every frame, regardless of the move state that's playing, in that case, idle. Then in the idle state, we're going to handle the transition to the run state. Now here, we want to handle the transitions between the states. So if the character is supposed to move, we want it to go to the run state. If it's supposed to move that frame, or the velocity is greater than 0, let's say. So we can say if parent.velocity.length is greater than a small value, we're going to transition to the run state. So we're going to call transition to on the state machine. And so we will have a run state in a second after the idle state. I'm actually going to create it now. So from move, I'm going to press Ctrl A, create a player state, call it run, and we'll create its script in a second. But that way I can transition to, remember we have to pass the relative path to the state. So it's going to be move/run in that case. Now, you might also want to check that the player is still on the ground. So to do so, the kinematic body class has a method called isOnFloor that is going to return a boolean. It's going to be true if the character is on the floor. So you can say if the player is on the floor and the parent move state's velocity property has a length that's greater than 0.01, because remember, parent points to the direct parent of the state. In that case, it's the move node that has that velocity variable that we can use. In that case, we'll transition to the run state. Note that isOnFloor is only going to be true if the character moved that frame, or rather, it only updates when the character moves. That's why we call physics process in the move state before calling that function, because we first move the character, then we check if it is on the floor. In the enter state, we're also going to do something. So when we enter the idle state, we want to make sure that the character does not move. So one thing we can do is reset the velocity vector on the move state to 0, vector 3.0. That way we ensure that we don't trigger that condition if we forget to reset the velocity to 0 elsewhere. Finally, that's where we can start to play animations. We're going to use the skin variable from our player state class for that, and we're going to call its transition to method and transition to skin.states.idle. This will go to the idle animation node in the animation tree on Mannequin. I'm going to save that, and we're going to add the missing piece of the puzzle, the run state. So you can copy all that code, because we have some boilerplate in there we're going to reuse. Right-click on the run node, extend script, and save it in the state directory. And from there, you can paste all your base code. Now I'm going to remove the lines that are specific to the idle state here. And here's what we're going to do. We want to go back to the idle state when you release the keys and you are not moving on a given frame. We can use the velocity again for that. So if the parent node's velocity's length is lower than 0.01 or 0.01, we can go back to the idle state. State machine dot transition to, and we're gonna go to move/idle. Again, if I go back to the scene, remember that we have to pass the path relative to the state machine to the target state. And we're also going to use the skin variable to transition to the run animation. So passing skin.states.run here. That way when we enter that run state, we try to go to the run animation. And again, the advantage of the setup that we have is that as your character gets more complex, you may have different transitions, animations in between everything, and this will smartly resolve the path to the run animation and play any intermediate thing. For example, after falling, you might have a short land animation that will play before the run animation, and that will be triggered by this transition to call. With that, we have to change one thing in our state machine because the initial state was set to move, and instead we want to use the idle state because only idle and run actually have transitions coded in them. Idle goes to run, run goes to idle. And you'll note that this is very close to our animation tree graph. The only thing is that it's done in code instead of being done with a visual editor. I actually wish we could reuse that editor just to visualize some kind of state machine, but as I said in the previous video, this system is not designed to support everything we need with the enter and exit functions that are really important in a state machine. Now let's see if everything's working. Press F5 and let's see that, note that it's working. So we're going from idle to run, but the run animation is not cycling. So let's go to Mannequin there, select the animation player and go to run in the drop-down menu. I'm going to move that out of the way and set it to loop. In general, you can do that for any animation that should loop. So idle was set to loop already. And you can do that for, what else is there? Fight idle. It should loop. Save. You can then play the game again and the character should run when you press a direction key and stop when you release the keys. Another interesting thing is note how we are only using one value here, the velocity, to detect if the character is moving or not. You could add Boolean properties to say the character is moving, is not moving, or whatever. You could store the move direction or input direction in a variable. That's another general guideline I want to share with you. Use as few properties in your classes as possible. Try to reuse the properties as much as you can. Again, the fewer properties that you have, the fewer mutations that you have or combinations of possible states for a given class you have, and the fewer bugs you will tend to produce, or the easier the bugs will be to solve as a result. This is general. You'll see through experience that you have to sometimes add properties to simplify your code, but again, general rule of thumb guideline that I recommend following. But with that, we have the base character moving on the ground. We're gonna take it to the air next.